welcome back again. We're going to continue our chapter on geosciences, in particular the theory of plate tectonics. In the last lesson we talked about how initial ideas of Alfred Wegener about continental drift were further developed to the current ideas or the current theory of plate tectonics. And we talked about how these plates, their positioning coincides with places where there are known volcanoes or earthquake activity. And we'll explore that a little further in this last lesson of this chapter. So let's now focus on what happens at these plate boundaries, where the action is. And basically there are three types of actions or activities that can occur at plate boundaries that result in these dynamic events. One is what we call transform boundaries, and basically this is when two tectonic plates slide past each other. And I'll sort of take a couple of books here, and when they slide past each other, and the result will be earthquakes or volcanoes as a result of the release of energy when this sliding and grinding past each other occurs. A second type of phenomena is the divergence or the spreading of the boundaries. So imagine if you have two plates and they spread apart. And when they do so, that can allow some magma from beneath to flow upwards. And we'll see that when this magma flows forth, it can do so in the form of volcanoes, or it can be somewhat gradual, but it can form mountain ridges, sometimes in the middle of ocean floor, such as the North Atlantic Ridge. The bottom drawing shows these first two types of interactions between boundaries, the transform and the divergence. And below you'll see, for example, how transform boundaries can be the site of earthquakes. It's not so clear in this drawing. And that at the divergence between boundary plates, you can form an oceanic spreading ridge, for example. Now, just to give you a few other terms, lithosphere refers to the upper layer of the Earth's crust, a sort of hard layer, and below that you have the more molten asthenosphere. And the third type of interaction between boundaries is what we call convergence, which means the cramming together. This can be the most violent type of interaction between boundaries. Imagine having two plates that come together, and when they butt heads with each other, something's got to give. Now, what happens often is that one of them is subducted below the other. Subduction means when one plate goes below the other plate, something like this. And that is shown in our drawing as the upper right type of interaction between plates. And further, it's shown as the lithosphere of one plate going below the lithosphere of the second plate. Now, the consequence is that when you have this convergence of plates cramming together, one being subducted below the other, you can form such things as ocean trenches, or you can form a ridge of volcanoes near convergent boundaries. You can also form mountains. When this subduction happens and one rises above the other, this can lead to a mountain chain, and we'll point out examples where there are mountain chains near the boundaries of platonic plates. Examples are the Himalayas, the Ural Mountains, and the Andes Mountains. Additionally, when an oceanic plate converges with a continental plate, this can result in a chain of volcanoes along this convergence, and sometimes also a large trench in the ocean near the convergence. An example of that would be the Marianas Trench, which is off the coast of the Philippines, which is the deepest trench on the globe. I want to show you now a few examples of what can happen when you have some kind of interaction between these tectonic plates. And the first example will be the assault of India on Tibet. It turns out, geologists believe that 60 to 80 million years ago, India, which has its own plate, the Indian plate, actually was about 6,000 kilometers, about 4,000 miles south of the Eurasian plate. and that India has moved northward, colliding with the Eurasian plate, and it collided about 10 million years ago, resulting in subduction. And this collision then led to the formation of the Himalayan mountain range, including Mount Everest. And the Himalaya mountains continue to grow today at a rate of about 1 to 2 centimeters per year. So they're getting higher and higher. And I'm going to show you now a simulation taken from the UK, United Kingdom's Geological Society, a simulation of this assault of India on Tibet and the resulting formation of the Himalayan mountains. Okay, so that is obviously a dramatic consequence of the interaction between plates. Another example of the interaction between plates is what we call transform boundaries. Again, remember that's the sliding of one tectonic plate by another and the rubbing of these plates, which build strain, which can then be released as earthquakes. And a good example of that is the San Andreas Fault in California. The San Andreas Fault runs on the coastal side of California, and you can see the locations of Los Angeles and then San Francisco. And it turns out that Los Angeles is on one side of this fault, and San Francisco is on another side, although it's along the line, but it's on another side of this fault. And these two parts of California are actually on two separate tectonic plates. We have the North American plate on one side where San Francisco is located, and Los Angeles is actually on the Pacific tectonic plate. And these are moving past each other because the Pacific plate is moving north faster than is the North American plate. And so the question is, with the San Andreas Fault, when will Los Angeles be further north than San Francisco? Okay, let me show you a second simulation to show you what I mean, because one is in fact moving north more quickly than the other. Okay, well, actually, it will take a long, long time before Los Angeles is further north than San Francisco. It's thought that this migration of the Pacific plate is at a rate of about 48 millimeters, 5 centimeters per year. So it's not moving very fast, but it is moving, and it produces this strain, which leads to these earthquakes that we hear about in California. A third example of what can happen as a result of the movement of these tectonic plates is the formation of island chains, and one example would be the Hawaiian island chain. As you probably know, the Hawaiian island is a series of now 8 islands in the Pacific. And geological evidence shows that the northwesternmost island is actually the oldest of these islands, and that the southeasternmost, the one we call the Big Island, is the youngest of these islands. They're not all the same age. They differ, their age differs by quite a lot. And geologists believe that they are formed as a result of the Pacific tectonic plate moving over what is called a volcanic hotspot. And as the Pacific plate moves over this hotspot, the volcanic activity erupting through the Pacific plate forms an island. And then the plate moves a little further and it forms another island. And in fact, there's evidence that yet an additional island is being formed or will be formed in the future southeast of the Big Island. So in this video, we're going to show how vacation islands can be made, the formation of the Hawaiian Islands. Okay, pretty neat, huh? Form your own vacation island. Now, if you look a little more at this map, you'll see that there are other island chains. Now, the Hawaiian Islands, actually there are 8 islands that actually exist now, but there are other smaller mountains that are below the ocean that once were part of this Hawaiian ridge. And there are another chain of mountains called the Emperor Seamounts, as you can see in this map, and another chain which still exists, the Aleutian Islands. And in each case, this chain of islands was formed by the movement of the tectonic plate above hotspots. Now, we live in the North American continent, so you might be interested in the geology of our continent and geological evidence in terms of the age of the rock and the composition of rock. Shows that the oldest part of our continent was what is shown in the tan or the light brown shaded area, northeastern Canada up into Greenland, well, all the way from Texas all the way up to Greenland. This is the oldest part, the oldest land mass that now comprises the North American continent. And that the other parts, east and west, were added over time. The Appalachian Mountains are the oldest mountain range in the United States. They're 300 to 450 million years old, and they're kind of getting worn down now. Whereas the Rocky Mountains, which are much taller, but they're also much younger. They're 60 million years ago, and also the Sierra Nevada range is a much younger age. And in this graphic, the parts to the left were some of the landmass parts that were added most recently to the North American continent. Just thought you might find that interesting. This closes our chapter on plate tectonics. We've seen that our big blue marble, this planet on which we ride, is a pretty dynamic planet. But the various geological events can happen on a very broad time scale, from very brief events such as earthquakes and the eruption of volcanoes to very, very slow events like the movement of these tectonic plates. And we've seen that all of this is a result of the enormous amount of thermal energy inside of planet Earth, and that this thermal energy produces a tumultuous roiling effect of the magma, resulting in these events. Now, in the next chapter, we're going to continue talking about geosciences, but we're going to focus mostly on what happens in the atmosphere and in the various cycles, including the water cycles. That is the environment that we experience. So we'll see you in the next chapter.